monopolies. What if we asked someone in the real world, hey, what do you think would happen to the price of a good if it was sold by a monopoly, where there's just one business selling it, rather than a competitive market where, that firm has competition? They'll probably say that, oh, the monopoly, I guess, would have a higher price because they have no competition. Let's see what economic theory says. Well, before we talk about monopolies, we have to talk about this new curve that we'll be working with a lot called the marginal revenue curve, MR. Now, you might remember from perfect competition that marginal revenue for a firm in perfect competition is always equal to price. Let's think about what that means. Marginal is the next one. Revenues, that's how much money you're bringing in. So if you're in perfect competition, if the price is $11, that means you're a price taker. Every item you sell is always for $11. So your marginal revenue, the extra revenue from selling one more item, is always $11. But here's the thing. A firm in a monopoly has market power. Here's the thing about market power. It's a double-edged sword. Sure, you're not a price taker anymore. You can basically set whatever price you want if you're a monopoly. But anytime you want to sell an extra item, you have to lower your price. See, in perfect competition, you can sell another item for $11, and so your marginal revenue would be $11 equals the price. But if you're in a monopoly, let's say you're selling 9 items for $11. Here, if you actually want to sell a 10th item, you have to lower your price. So let's say in this case, if you had to lower your price to $10 to be able to sell that 10th item, let's see, how much revenues were you making originally? Your total revenues originally, $11 each for 9 items was $99. And now you're selling another item, a 10th item, but now you have to lower your price. Here's the key. You have to lower your price for all the items, including all the previous ones that you used to sell for $11. So here your total revenues are only $100, 10 times 10. So it's 100. So if we think about our marginal revenue, how much extra revenues do we have now that we're selling an extra item? It's only $1. Our revenues went from 99 to 100. So even though we sold an extra an item at a price of $10, our marginal revenue wasn't 10, it was only 1. So our MR here was only 1. It was less than the price. And that's one theme that we're going to find here, is that the MR for a monopoly is always less than the price. Now let's look at what marginal revenue looks like graphically. It always has the exact same y-intercept as demand, so that's one thing to keep in mind. And it has exactly twice the slope. It's twice as steep. The reasoning from that comes from calculus, but we could just take that for granted for now. It always has twice the slope, same intercept, so here's what it looks like. Something like that. Couple things. One is, because of that, it always has exactly half of the x-intercept that the demand curve does. So if the demand curve has an x-intercept of 80, then the quantity here will be 40 at this intercept. Further, at this intercept over here where MR is 0, right? The y value of MR is 0 and the quantity is 40. This is when you're maximizing revenue. So that's how you maximize revenue, but how do you maximize profit? Well, the golden rule here is MR equals MC. Again, that comes from calculus, so you just have to take that, take that as given for now. But if MR equals MC, you are maximizing your profit. So here, your MR, this black line intersecting with the MC, this upward sloping red one, that's over here. So that's how you know the quantity that you want to produce. So let's say this quantity is 35 or something. So given this graph, a perfectly competitive firm will produce over here. But if you're in a monopoly, 2 steps. Step 1, find the MR curve. Basically, it's half the x-intercept, same y-intercept, so twice the slope. But then see where that MR intersects with the MC, and that's the quantity you're going to want to produce. But here's the thing. For the price, and it's a really common mistake to use that y value as the price, here's what you want to do. You want to go up to the demand curve at that quantity. So at that quantity where MR intersects MC, that's equilibrium quantity, but that's not the equilibrium price. You want to go up to the demand curve. Because, I mean, hey, if you're selling a scarcer quantity of the good compared to perfect competition, people are willing to pay more for that. So you're going to be able to charge more. So either way, that's your price for a monopoly, which is always higher than the price for perfect competition. So remember at the beginning we thought about what the person off the streets would say? Well, I guess their instinct was right. A monopoly will always charge a higher price than a firm in perfect competition. But now we can even specifically say what the producer and consumer surplus would be. The consumer surplus would be anything above that price, so that's just this area underneath the demand. That's the CS. And the producer surplus is everything below that and above the MC curve, so that's all this region over here is the PS. So we have the CS and the PS. Notice though that compared to the perfect competition market, that's called the socially efficient point because it has no deadweight loss. What we observe here is if you're in a monopoly, your CS and PS add up to less than what it would have added up to, all this, if you were in perfect competition. So this region over here, this triangle, is called deadweight loss, and that's how inefficient we are because we are a monopoly instead of perfect competition.